Now, what's the second step? Is to start working with the data, collecting the data, and getting conclusions or the results of your project. And this is why the next section is data collection, how to collect data, how to enter it into the computer, clean it, and how to manage it. So this section is going to be about the research process. And the research process, as I would like to introduce it in this topic, is starting from the planning. You know what the planning is. It's where we plan our design, the study, the proposal, and so on and so forth. We have the study design. We have the data collection, where we collect data into our study. We have the analysis part. But in the analysis, you have the entry, data entry. You have the data cleaning, the management, the data analysis, and the reporting. Okay? So you know what data collection is, but I'll talk a little bit about it. Data entry is where you put the data into the computer. The data that you collect, you put it into the computer. You clean the data, because whenever you put data into the computer by manual data entry, you will have mistakes. You will always have mistakes. So you have to make sure that you clean the data. Now, data management is where you modify, play with the data. I'll give you an example. Usually you measure height and weight on patients. Are you interested in height and weight? No. People or physicians are interested in the body mass index of the patients. Body mass index is a combination of weight and height, and it's calculated by weight divided by height squared. And when you fill out a questionnaire from people, you do not ask about their body mass index. You ask about their weight and height. But when you reach the data, you manage the data so that you can calculate new answers, which is the body mass index, for instance. The data analysis is where you analyze your data and you get the percentages and the p-values and so on. And finally, the reporting, where you publish. Now, usually I ask, where do you think statistics is involved in this whole part? And some people would tell me that statistics is involved in this part. Analysis till the data analysis. My answer would be that statistics is involved from the very beginning to the very end. Why? Because in the planning stage, the most important thing you have to plan is what? Is the sample size. How many people are you including into your study? Because if you're including 100 people, it's very much different than if you are including 1,000 people. So this is why you have something called sample size calculation. Sample size calculation is where you statistically determine what is the sample size you need to include into your study. And it should be done at the planning stage. Design, of course, the way I design or I analyze a clinical trial is very much different, and you have seen it with the odds ratio and the relative risk, and these are simple stuff. So the way you analyze different study designs is different. So you have to understand each study design, how is it analyzed statistically to be able to plan it well. Data collection, you need statistics for data collection. And I'll give you a simple example. If I want to collect information on age, and age is the simplest piece of information you will collect from patients. Age could be measured by so many different ways. You can ask about date of birth, where you subtract it from today's date and you'll get the exact age. You can ask, how old are you? You can ask, are you less than 20, between 20 and 30, 30 to 40, 40 to 50? There are so many different ways you can calculate age, which is very simple. Now, how do you decide which way or which format you are going to collect information on age? Now, you have to understand, once you collect the data, how are you going to analyze it? So you have to know statistics to be able to collect information in the right format. Under analysis, of course, you need statistics for data entry, because you are entering data into the computer and you have to have a structure of the database. Data cleaning, you have to do some analysis to clean the data. Management analysis, of course, you are calculating, so statistics is there. But finally, do you need statistics to report? Do you need statistics to publish your data? I would say yes, absolutely. So why do you need that? Because I might tell you something like the following. Assume that I did the results, I did the analysis, and I found a hazard ratio of 3.0 with a confidence interval of 1.5 to 4.5, and P for trend, for example, of 0.001, and so on and so forth. Would you be able to report it to other people if you do not understand it yourself? Absolutely not. This is why you have to have some statistical expertise to be able to report the results of your study. Now, what I mean by having statistical expertise, I don't mean that you as a person, as a physician, as a resident, is going to be professional in statistics. Absolutely not. But all what I'm saying is that you should be able to understand basic statistical terms so that when you sit with a statistician, you could be able to analyze and work and communicate with the statistician. Now, so what is statistics? Statistics is a field of science concerned with collection, organization, summarization, and analysis of data. So this is the definition. And all of these are called descriptive statistics. Now, there's another type of statistics that's called inferential statistics. So what is inferential statistics? It's drawing of inferences or conclusions about a body of data when only a part of the data is observed. In other words, I'm not taking the whole population, I'm taking a sample. So this is why inferential statistics is when I draw conclusions on the population from a sample. And I will be talking about more details. So biostatistics is the application of statistical methods to biological and health-related questions. It is a component required for the completion of an epidemiological study. Remember, we are talking about quantitative research. We're not talking about qualitative. Qualitative research, no statistics is involved. Now, there are two types of variables. One is called categorical, one is called continuous variables. Categorical variables is as the term category mean. What does category mean? It's a group, right? So a categorical variable is a variable in which people are placed in different groups. For example, the sex of the patient, gender, is male, female. So I can either put the person as a male or a female, two categories. Death, yes, no. Blood group, A, B, and O. So different categories, and so on. Education, I can say illiterate, elementary, secondary, university, and so on and so forth. So all of these are categorical where a person fits into one category. On the other hand, we have something called continuous variable. Continuous variable is a variable that has continuity. For example, if I'm talking about age, I can have a person who's 20 years, or 21, or 22, or 23, or 24. So there is a continuity in the answers to the variable. Blood pressure the same, weight the same. Now, you might tell me that age could be done as less than 50, more than 50, right? If I do it as less than 50, more than 50, it's not continuous anymore, right? It is categorical because I place a person either in the young group, irrespective of 50 is the cutoff, in the young or old, right? So a continuous variable could be divided into a categorical variable. Now, another point, here I have death, yes, no, male, female, A, B, and O. So I would like usually to ask a question about what is the first thing that comes to your mind when I say statistics, and I expect an answer to be numbers, right? I expect people to answer me as numbers. So the first thing that comes to your mind when I say statistics is numbers. And I say, how am I going to apply statistics on something that has no numbers? These are yes, no, male, female. These are not numbers. This is why I have a concept in statistics that's called coding. Coding means, although it is not numbers, but I assign numbers to them. So a male, I would give them number 1. A female, I will give them number 2. Now, does it make a difference if it's 1, 2, or 2, 1, or 0, 1, or 0, 2? No, it's a code. But instead, because statistics, I cannot apply it on letters like male, female, yes, no. I give numbers to those people so that I can apply statistics on them. So this is the concept of coding. Now, the reason why I told you about all these, the different types of variables, to establish the concept that all the analysis that we do, it depends on the type of variable. So the way we deal with the categorical variable is different than the way we deal with a continuous variable. So steps involved in a research project once we finish the proposal, we have the data collection, we talked about it, but here I have to structure a database, and then I have to enter, clean, manage, and then analyze. Let us talk about each one alone. Data collection is the collection of information that will be used to answer the research question. It has to be specified in the proposal. What are the questions that you are addressing? You're collecting information on age, gender, physical activity, family history, diseases, quality of life, so on and so forth. It depends on the objective of your study, your literature review, right? And based on that, you decide what are the information you collect. Now, it could be done through questionnaires. You can give questionnaires to people. They will fill it up and give it back to you. Or you can do interviews. You can sit in front of somebody and ask them questions, and they will answer, and you will write. You can do it by data abstractions. You can go back to the medical records and get information from the charts. So there are so many different ways. The objective here is not to talk about what are the ways and how is it done, as much as to establish that there are so many different ways to collect information, okay? Even to structure a questionnaire, if you want to structure a questionnaire, it's not very straightforward. You have to make sure that the questionnaire is developed in a proper way, it is tested, it's piloted, and so on and so forth. It's better to use validated questionnaires. What do we mean? There are some questionnaires that have been validated in different populations. For example, we have GDS, Geriatric Depression Score or Scale. What does it mean? It means to assess depression among a geriatric or old people, senior people. There's a specific scale with maybe 20 questions. It has been used, it has been validated, it has been confirmed. So what you can do is you can use it, but you might have to translate it to Arabic. So translating it to Arabic might take something that we call forward translation. You translate it from English to Arabic, and then you do backward translation, which means from Arabic to English by a different person, and you see the translation, how much effect did it have on the content of it. So there are so many sophisticated ways of doing data collection forms and so on, but I'm just introducing the topic rather than giving details about it. So this is an example that I usually use in something like this. For example, myocardial admission to an emergency department at a certain institution. Okay? So assume that the institution is interested in assessing the characteristics of people admitted to the emergency at the institution. In other words, they want to see what is the age distribution, what is the gender distribution, what is the admitting diagnosis, and so on and so forth, and what is the outcome, the survival, the discharge, and so on and so forth. So this is a questionnaire that people developed with the serial number, medical record number, age at presentation, the sex of the patient, marital status, and so on. Again, the content, I'm not talking about the content now because it's dependent on the study and the objective that you are doing. Now, once you collect the data, you have the data on paper. The second thing is, or the next part, is to transfer this data from the paper to the computer. How do we do that? I have to first structure the data set. What do you mean, or what do I mean by structuring the data set? When I want to enter information into the computer, I have to tell the computer, if I enter 1 in this place, it means that the patient is a male. If I enter 22 in this place, it means that the age is 22. So I have to tell the computer that these are the numbers that I will enter, and I have to inform the computer, this is what you expect in these places. So structuring a database, I will just show you this database structure. Now, this is a program called SPSS. It is the most used program for statistical analysis. It is user-friendly. It is very simple, relatively speaking. And it's called SPSS, which is Statistical Package for Social Sciences. So it's Statistical Package for Social Sciences. So the SPSS is a program that originally was developed for social sciences, but now it's heavily used in the medical field. Now, here I have structured the database. You remember the questionnaire that I just showed you. The first variable was the serial number. I specify what's the serial number. I specify what's the medical record number. And these are the type of variables. You remember when we said we have categorical, continuous, and so on? I specify them here. Scale is continuous. Nominal is a variable that is categorical. Ordinal is another categorical variable. This is the label of the variable. And these are the values. Didn't we say something about the coding? The coding is when I give a number. But the problem is, if I give a number, I might forget what this number is. Did I give the males 1 or 2? Or did I say yes is 1 or 0? And so on. So the SPSS would allow me to put here information about who are the males. In this case, it's 1 male, but there's a continuation for it. 2 is females. Here it's 0 no, and 1 is yes. So this way, the computer now understands that the first variable is the serial number. The second is medical record number. The third is age. The third is sex, and so on. So I can structure my database. Once I structure my database, the next step is to enter information into the database. So data entry is a long process, and it might take considerable efforts. What does it mean? It means entering the information or the data into the computer. Most of the times is done manually. Yani most of the times you'll have paper in front of you and you punch in every and each single number. Okay? Now, sometimes it's done electronically. You remember when we used to do the exams, you have an answer sheet and you circle, and then you put it in a feeder. This could be done in research, but it is not widely used. Now, most of the times done manually, but you have something called single data entry and double data entry. Single data entry is when the data is entered once, only once. So you have one computer, 2, 3, 4 people alternate on entering the 300 questionnaires that you have. Okay? But sometimes I might decide to do double data entry. What does it mean? I have 2 rooms, 2 computers, 2 sets of the questionnaires, and 2 different people or different set of people will enter the data into the 2 computers. So eventually, I'll compare these 2 databases or the 2 computers, the data that was entered, and I compare them. So I can identify any small mistake that was done. So this is for verification of the quality of the data, but 95% of data entry is done through single data entry. Once I enter the data, this is how it looks like. Okay? So here I have the first variable called serial number, MRN, age, sex, marital status, weight, height, and so on and so forth. This is the first patient, the second patient, and so on and so forth. So it's similar to Excel, Microsoft Excel. If you, I'm sure you know how to work on that. But somebody might ask me, we put 1 and 2 for sex, male and female. Why is it put in letters? I would tell you, the SPSS would, since you have told the SPSS, if 1 is male, 2 is females, it put it as 1, 2, but it shows it to you as male, female. So that you do not only look at numbers, you look at the words that you have entered. So all of this are entered as numbers, but there's an option in SPSS to ask the computer, give me the values, don't give me the numbers, give me the codes that I entered. But anyway, this is the data how it looks. Okay? Now, the second step, once I enter the data into the computer, I have to clean it. I have to make sure that the data is clean. What does it mean? Data cleaning means that I have to identify any data entry mistakes, and I have to correct for such mistakes. For instance, if I clean or if I look at the data, for example, I might find age to be 170. How come? Because maybe the patient was 70 years old, but by mistake I put 1 and then 70. So it's a clear mistake. Sometimes the sex of the patient, instead of putting 1 or 2 for male, female, by mistake I put 3. What does it mean? It means nothing. So the point is, I have to spend considerable amount of time to verify that the data entry I put or I did is correct and good enough. Now the data management is, I briefly told you what data management is create new variables based on different criteria. Okay? Basically, we have 3 scenarios in data management. You have 3 scenarios. One scenario is when you want to calculate. Okay? What does it mean? I want to calculate, for example, the body mass index, which is equal to weight divided by height times height, or height squared. Okay? So here, I want to manage my data. I want to create a new variable that's body mass index based on two variables that are weight and height. Sounds good? Now, the second scenario, now of course, calculation, you might do so many things. For example, recently, I did a score about MELD. MELD is a score that combines creatinine, bilirubin, and INR, right? It combines the three of them into one score that gives information about the disease of the patient. Another one is Apache, another one is SOFA. All of these are scores where you have to combine and calculate, and it could be used by SPSS. Now, the second scenario is recoding. Assume that in this case, I have marital status being married, single, and widow. This is how I decided to collect information on. But when I collected my data, I found only one person who is widow, okay? Or two people, or whatever, very small number. So what do I decide to do? I decide to change the coding into a new variable that I call marital status, marital for example, underscore n, meaning the new marital status, and I want it only to be 1 or 2. 1 is married, and 2 is single or widow. Okay, is it clear? So basically, I am recoding. So I have the coding for the marital status, but I'm changing the coding. Okay, I want to combine the single and the widow together and the married alone. Okay, again, you might have so many different examples based on your objectives. A third scenario is where I want to categorize. So in other words, assume categorize. Assume that I have, for example, age, or let us take another example, systolic blood pressure. I might want to divide it into 3 groups: less than 20, between less than 120, 120 to 140, and more than 140. So I will say this is 1, this is 2, this is 3. So from a continuous variable that I have, which is continuous, I want to change it to a categorical variable, which is 1, 2, or 3. So these are the 3 broad ways or methods or scenarios where I need to put or do data management for my data. Now, data analysis is where I do descriptive and inferential, and I will start with this in a minute. But usually I ask a question, which one do you think is the hardest part? Data entry, data cleaning, data management, or data analysis? Most of the people would say it is data analysis. And I would say the easiest part is the data analysis. Why? Because the hard job is to do a good data entry, a good cleaning, a good management, and once you have all the information, anything that I want to do, I will do it in a split of a minute. Okay? In 1 minute, I can do all the analysis, or a lot of analysis, but the problem is when it is not a clean data, I have to go back and forth and correct. Okay? The analysis is done by the computer. If I was giving you a practical workshop on SPSS, for example, you will see how fast you can get very complicated results as long as your data is good.